You guys said that, yes, it was a function because of the vertical line test.
The equations are y equals negative x.
Y equals negative x. Everybody see y?
Yep.
Okay, and for a set of ordered pairs, we're going to say it's the set of all points x comma y, because that's how you write points, such that y equals the opposite of x. The set of all points x comma y such that y is equal to negative x. Okay, so domain. Domain you said was script R because it goes forever up, forever down.
Yep.
Range is script R because it's forever left, forever right. All diagonal lines are always script R on both of those.
Yep.
Okay? Page 7.
In math, it's a
Yes, it's a function.
yep. Passes a bird test.
All right, what shape we have here?
That'd be a
Parabola.
Yeah.
Okay, and it's a sad face parabola. So if I were to go and write the equation for that thing, what's the parent function of a parabola look like?
Squared.
Right, y equals x squared is the parent function. So this particular parabola has been shifted how?
Upside down.
It's upside down. So what makes it upside down?
The negative.
I need a negative on my x. Okay, what else?
Yeah, it's to the left.
Okay, so the vertex was here. It's shifted up 4 and 3 to the left.
Yep.
Right, so to write my equation, it's going to look like this. You can use an f of x or a y. I have a negative and then a parentheses because of the left-right shift. It's always the opposite of what you think on a left-right, so it should be a plus 3 to show that it's moving left 3, a squared to show it's a parabola, and a plus 4 to show you're moving it up. So there's your equation. Yes, it's a function because it passes the vertical line test.
So on the parabolas, it's a positive 4 because it's going up 4, but it's going left 3, it's a positive 3. So you
Yeah,
already flip.
this one's always the opposite.
Okay.
Okay? This negative flips it upside down. That moves it up 4.
Point is negative 3.
We're ignoring the ordered pairs for this particular one because you're not going to be asked that question in Chapter 4 at all. It's something that pops up again in Chapter 8, so I'm just doing some exposure on it throughout this lesson. So domain. Does it go forever left and forever right?
No.
Well, let's
Well,
see.
yeah.
Oh yeah, I guess it doesn't, right?
Yeah, it would forever left and forever right. So my domain is script R. And my range, does it go forever up and forever down?
No, it goes
It does
from
not.
negative 3, 4 to infinity. Okay.
I would say you want to start at the lowest number and work your way up. So you would
Oh.
start at negative infinity and work your way to positive 4. So negative infinity all the way to positive 4. Bracket around the 4 because you're including the 4 as part of your answer. Does that make sense? Okay, moving on to the next one.
How does it look on the website on Oxford? Like how is the
We'll get to some of those, and that's why I call this 4.0. This is kind of information for the entire chapter. And, I mean, some of them they'll ask you, like domain range. They'll ask you to write the parent function. We'll go through some of those before we actually assign that lesson, which we'll probably be doing that tomorrow. We won't get done completely with this today,
We got a
probably.
horizontal line here.
Horizontal line, okay? What horizontal line that crosses the y-axis where?
Negative 5.
1, 2, 3, 4, 5. Draw a horizontal line through there. So yes, it passes the vertical line test.
So
Script R.
on domain.
I am going to write a set of ordered pairs on this one because it's not too bad. It's the set of all points x comma y such that x is an element of the real numbers, and that's a comma there.
X is an element.
I'll explain in a second, and y is always equal to negative 5. Okay, so that's what,
Script R.
yes, that's a script R. So write it down and then I'll explain it.
So x can equal any real number.
Yep.
And y has to equal negative 5.
Yeah, that's all it means. So this is just set notation, so we have set brackets. It's a set of all points. that look like this, x comma y, such that x can be any number. This little thing right here is like a C with a line on it, but it means x is an element of the real number system, and y has to be a -5 no matter what. Okay? Domain. So that domain, it was pretty much up here, right? It said it could be any element of the real number, so my domain is script R, because it goes forever left and forever right. It does not go forever up and down. The only y value you ever encounter is what? So this one you actually have to use set brackets for your range, because they only have one element in the range. So the set, including the number -5, and those brackets are in the keypad if you need them. It may already be there for you, and you just put the number inside of it. I don't remember. Everybody okay with that page?
Yep.
Okay, next one.
Vertical,
-3.
-3,
Yep, just a vertical line this time instead of a horizontal, but
not a function.
not a function, correct. So what happens when it's not a function?
There's, there can't be a,
Well, as soon as you hit no,
X.
as soon as you hit no, two boxes are going to pop up. What do they want in the two boxes? 2 points to prove it's not a function.
Oh, yeah.
So that's a vertical line that crosses at -3.
So it has to be just -3, 5, -3, 4.
-3, anything you want, right? So any point on this line will be acceptable, and any point on that line would have a x value of -3. So -3, 5, -3, 0. -3, anything you want. Okay, once again, this is not too bad to do the set of ordered pairs on, so we'll do that. It's,
Before you go,
yep,
I want to try it by myself real quick.
all right.
See if I get it.
The set of all points.
Does it matter if we put X or Y first when we're talking?
Typically, you do alphabetical order,
Okay, so
but it wouldn't be wrong. So it's the set of all points, x, comma y, such that what?
Y is any real number.
X equals -3 and Y
Yeah.
is the element deal. R.
Y is an element of the real number set. And there we go.
Oh.
Which pretty much tells us our domain and range.
Yep.
Domain is the number -3 only, so we make a set bracket with a -3 in it, and range is script R. Everybody good with that?
So you're gonna get
Is this some sort of parabola?
Y equals X.
Yeah,
Where?
it's a parabola that's been shifted how?
To the right one and
Uh-huh.
up one.
Right one, up one, and it's not upside down, it's a happy face. So let's graph that parabola. Right one, up one is going to give me a vertex right there. Anybody remember the pattern that I use to find other points on a parabola if there's no compression or stretch?
And then go up 1 over 1.
Up one, over one,
Then over 2 up 4.
over two, up four. Why does that pattern work?
Because you're just doubling.
You're just squaring,
Yes,
right?
right.
2 squared is 4. If you wanted to do another one, you could say over 3 and up how many?
9.
9, because 3 squared is 9, right? Over 4 up 16. You could continue with that pattern if you wanted. All right, so if I draw my parabola here, it's going to look something like this, right?
Yep.
So there's my parabola. We're going to skip the ordered pairs on that one. Is it a function?
Yes.
Yep. Vertical line test. Okay, forever up, forever down, forever left, forever right. What will it do?
For left and right.
Okay, so my domain is
Script R.
script R.
But it can only go from infinity to. Oh, I guess you have to go.
Start at the
from
bottom.
So 1 to infinity.
1 to infinity.
You're including 1, so bracket it.
Okay, there you go. Everybody okay with that?
Yeah.
Uh-oh.
Is the square root just like the line from the axis?
What does the square root look like?
Is it just the
Which we, it's the, yes, like half of an arch. It's like a half of a parabola lying on its side.
Yeah. So you're gonna go
It's
to
like something shooting up out of the water. So how has how's it been shifted?
was down 9?
Okay, 1, 2, 3,
left
4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7. So the vertex of my square root will be there. What pattern does it make when you do it?
It's a sad one, right?
Well, it's a parabola lying on its side. It just takes the points you had on the parabola and inverts
So it'd
them.
be like
So it's still a 1, 1.
It's still going up, and then
But instead of over 2 up 4, you go over 4 and up 2.
yeah.
Or over 9 and up 3, because what's the square root of 9? 3. So 9 up 3 would be right here. So we got this thing looking like it's shooting up out of the water. Okay? And if there was a negative, it would look like it was shooting under the water. Pass the vertical line test?
Yep.
So yes, it's a function. Now if you were to put a plus or minus in front of this, then that would mean to include the bottom half of the parabola, and then it would not be a function. So typically in a functions chapter, you're always going to see this with just a plus or just a minus. Okay, skip this set of ordered pairs for this one. Okay, domain. When you scan this thing from the left to the right, where do you see that picture?
It's gonna go from
Starts at
negative 7
Okay.
negative 9.
-7.
to infinity.
Whoops, I wrote 9
-7.
To infinity.
to infinity. Because if you start at the left and move your way to the right, this graph continues to go forever right. Okay? How about the range? Look from the bottom to the top.
So it's gonna go from negative 9 to infinity.
-9 to positive infinity. Okay? So the square root function, you're never going to see a script R in the square root. Okay?
It's like its packet's never ending.
It's kind of big, but it's very helpful throughout the whole chapter. You'll see. All right. Next page. Ooh, what kind of function is that?
It's not one.
It is a function. You may know what it is?
It's a quadrilateral.
No. It is a reciprocal function. There's the parent function to the reciprocal. It's been shifted. So if I were to put a number inside it, like right here, that's my left-right number. If I put a number on the end, that's my up-down number.
Okay, so
If I put a negative in the front, that flips it.
no, left 4, because it's opposite.
Left 4 because it's opposite. I have no up-down number at all. I do have a negative flipping it upside down. What's the 8 do? It's a vertical compression stretch number, right? So if this number is bigger than 1, if this is bigger than 1, what does it do? It's on the sheet right there in front of you. If the absolute value of A is greater than 1, what does it say? A is greater than 1.
Then it's a vertical compression?
I think it's a stretch. Look for this.
Oh, yeah, vertical stretch, yeah.
Yeah, if the absolute value of A is greater than 1, then you have a stretch. So the 8 that's right here makes it a stretch. Okay, so
You're going to go
that number right there takes it and moves it.
down 8.
Left, that's a horizontal translation. Left 4.
Yeah.
That's a vertical stretch of 8. And the negative sign makes an x-axis reflection. Does that make sense? What
Are
is...
you going up 8 or down 8?
No, a vertical stretch does this to it. It does this to it. Okay?
Oh,
It's not moving it. It's not doing this to it or this to
Alright,
it.
got it.
It's just taking it and stretching it out. Okay? So the parent function on your parent function sheet, the parent function for the reciprocal looks like this. So we've got to take that picture and we have got to move it left 4, flip it upside down, and stretch it by 8. Okay? Which we're just going to kind of guess on the stretch part of it. So,
It's going to be a quadrant 2 in the...
okay, so anytime you're going to shift a reciprocal function, shift it around the origin because that's where your asymptotes intersect. Everybody agree that that's your vertical asymptote and that's your horizontal? They intersect at the origin, right? So do your shifting based off the origin, and then you can shift your asymptotes. So I have to shift this thing, what, left 4?
Yeah.
So go left 4, and that's going to be your new origin.
You could basically make it different, like, that could be your X, like, your axis.
Yeah, that's what you do. Once you have your new origin, then draw in your X or your horizontal and vertical asymptotes.
You're just going to flip it from there and then.
And so from there, instead of having a curve in this corner and this corner, I'm going to have it in these corners because I have a reflection. And because there's a stretch, I'm going to not pull it in as close to the corner here. I'm going to make it a really wide corner.
So we don't have to make it like exact.
You don't have to give me an exact point now. Okay, and if you needed an exact point, then you would just pick a number for X and put it in here. You say, hey, what if X is a 1? What point would that give me? All right, so we're not going to do sets of ordered pairs on that one. But we do need to do domain and range. So when you scan this thing, it does go forever left and forever right, but there's this little hole in the middle. When you look at -4, there is no point on this curve that has an X value of -4. So that means that X can't be -4. So if it can't be -4, how do I write that in interval notation?
So it's going to be.
So start at the left of the graph. I start at the left. I've got -infinity. I want to go all the way to -4, but I can't use the -4. Then I union that with -4 to positive infinity, just leaving out the -4 once again. We did that sum in chapter 2. Everybody okay with that?
So the range is going to be.
So range, what can my Y value not be?
0.
Yeah, scan up and down. This graph exists everywhere from bottom to top except for at 0. So my Y cannot be a 0. But they don't want to know what it can't be. They want to know what it can be.
So negative infinity to 0,
Yep.
don't include it, unite it, 0 to infinity.
There you go. -infinity to 0, unioned with 0 to infinity. Everybody okay with that one?
I guess so.
That makes sense, Jesse?
Yeah.
It's kind of the harder one. You're right about that. Okay, so let's see. Do we have time for one more? What's next? All right, so what's this one look like?
That is a
This is the one you guys struggled with on the last test.
circle.
Okay. Because this is simply an x minus 0 squared, right?
Yeah.
So I do. You're right. It's a circle.
So that's
Where's-
your center.
Okay, what's your center? Center is
3.
at
0, 3.
0, 3. And what's my radius?
4.
4. Square root of 16 is 4.
At
Remember,
this time, please
this
repeat
is
to cross-country runners.
this is radius squared. This is radius.
So it's not a function, it's a circle.
Yeah, you're right. It's going to fail the vertical line test. Okay, so let's graph that thing. The center is at what, 0, 3?
Yeah.
So 0, 3 would be right here.
You're going to go 4 out from each.
Yeah, go 4 in each direction because your radius is 4. So there's another point. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3,
You could
4.
almost make a square with this.
Yeah, you just have to.
Yeah, I'm not very good.
I'm not very good at drawing circles either. Okay, but I do need to give 2 points to prove that it's not a function. So I would probably choose to give these two right on top of each other here, right? So that's at 3 plus 4, 7. So this one's at 0, 7,
0, negative.
and 0, negative 1. Okay, that would prove it's not a function. We'll skip the ordered pairs on that one. Okay, domain and range. That circle is contained completely between what two x values?
-4,
And
positive 4.
positive 4.
-4 and +4.
You're including those, so you bracket both of them. Right?
Yep. -4 to +4 in brackets.
So -1 to 7.
-1 to 7. for the vertical. Everybody good with that?
Yes.
All right, we're gonna stop there for today.
Yes.